In this video tutorial, we're going to do some practice problems where we're working with moles. And so let's just get started. In this first one, you're asked to find how many atoms of sulfur there are in 227.3 grams of sulfur. So we need to go from grams to atoms. And so we're going to be using molecular weight and Avogadro's number to do this. What you want to do is start with what they've given you, which is 227.3 grams. And so you know that we need to get rid of grams, and you can do that by using the atomic weight of sulfur. And if you divide by that, that'd be 1 mole over 32.07 grams of sulfur. Grams cancel. And then now we need to get rid of moles. That is where you can use Avogadro's number. If you multiply by that, 6.022 times 10 to the 23 atoms over 1 mole. Moles cancel. And that gives you 4.27 times 10 to the 24 atoms of sulfur. In the next one, you're given the weight of a penny, 2.5 grams, and you need to find how much a mole of pennies weighs. So this is basically asking you for the molecular weight of pennies, which is always given in units of grams per mole. So let's start with what we have. We have, 2.5 grams is 1 penny. So we need to get rid of pennies and somehow relate moles in there. Well, this is where we use Avogadro's number again. So that large number of pennies in 1 mole, pennies cancels, and now we're in units of grams per mole, and that gives you an answer of 1.51 times 10 to the 24 grams per mole of pennies. In this next one, you are given the molecular weight of ethanol and how many molecules of ethanol are there in 500 milliliters. So we need to go from units of volume to number of molecules. So first let's get rid of our volume and change it to a mass, which is what we can use the density for. If you multiply by the density, you get rid of milliliters. Then we can get rid of grams using our molecular weight. 1 mole over 46.07 grams. Grams are gone. Now if you get rid of moles to get molecules, we use Avogadro's number. 1 mole. Moles cancel. Now we're in units of molecules, which is what we want. And that gives you 5.16 times 10 to the 24 molecules of ethanol, ETOH. Okay, in this last one, you're asked to find the mass of a single atom of the following elements. So we need to go from the atomic weight, which is grams per mole, to grams per atom. So for silicon, you just start with the molecular weight, which is, let's see here, 28.09 grams in 1 mole. And if you multiply that by Avogadro's number, then that would be 1 mole, or if you divide by Avogadro's number, 6.022 times 10 to the 23 atoms. Now you have grams over atoms, which is what you want. And that gives you 4.66 times 10 to the minus 23 grams for silicon. You would solve for rhodium and antimony the same way. And when you do, you find that the answer for rhodium is 1.71 times 10 to the minus 22 grams per atom, and for antimony it is 2.02 times 10 to the minus 22 grams per atom. And that's it.